Hello everybody, welcome back. So far we have discussed few concepts and let us proceed with the next ones. Laws of chemical combinations. There were few basic laws formulated to understand the behavior of the elements combining to form compounds. Fine. So there were basically five laws. That is law of conservation of mass, law of definite proportions, law of multiple proportion and Gay-Lussac's law of gaseous volumes and Avogadro's law. Let us go one by one into the topic. First up, law of conservation of mass, and this was formulated by Antony Lavoisier in 1789. What he stated was matter can neither be created nor destroyed. And thus he came up with his observations that in all physical and chemical changes, there is no net change in the mass during the entire process. And hence he said that matter can neither be created nor destroyed. Next comes the law of definite proportions, which was given by Joseph Proust, and he stated that a given compound contains exactly the same proportion of elements by weight. And let us see how we came up to this conclusion. So what he did was he took two samples of cupric carbonate, and one was the natural sample and one was synthesized. So in both the samples, when he compared the percentage of the components in both the sample, that is percentage of copper, percentage of carbon and percentage of oxygen, both were exactly the same. So he concluded that irrespective of the source, whether it's natural or it's synthesized, a given compound always contains exactly the same proportion of elements by weight. Next is law of multiple proportion, and this was given by Dalton. And he stated if two elements can combine to form more than one compound, then the masses of one element that combines with the fixed mass of other element are in the ratio of whole numbers. So he says that when two elements combine to form a chemical compound, one element has a fixed mass and the mass of the other element which combines with this are in the whole number ratios when they give two compounds. So for example, let us consider hydrogen combining with oxygen to give a water molecule and to give hydrogen peroxide. In case of water molecule, 2 grams of hydrogen combines with 16 grams of oxygen. And in case of hydrogen peroxide, that is H2O2, 2 grams of hydrogen combines with 32 grams of oxygen to form hydrogen peroxide. In this case, we see that hydrogen has fixed mass, that is 2 grams, right? And whereas the mass of the oxygen is 16 grams and 32 grams, that is in the ratio 1:2. Next up, moving ahead, Gay-Lussac's law of gaseous volume. So Gay-Lussac formulated a law wherein he says when gases combine or are produced in a chemical reaction, they do so in simple ratio by volume, given that they are all in the same temperature and pressure. So for example, if you take hydrogen and oxygen, so hydrogen and oxygen are gases, right? So this is something I wanted to discuss when I was talking about compounds. Hydrogen and oxygen combine to give the form the compound water. In these cases, we see that hydrogen and oxygen both are gases and water is a liquid. So the properties of the elements of the compound are different. Individual elements are different from the properties of the compound itself. So hydrogen is taken to be 100 ml and oxygen they take it as 50 ml to form the water, that is 100 ml. Thus the volume of hydrogen and oxygen will combine, that is H2 and O. So hydrogen should be twice the volume than the oxygen, right? That is what is followed in this year. Next was the Avogadro's law, wherein he stated that equal volume of all the gases at same temperature and pressure should contain equal number of molecules. And Avogadro was the first person to make the distinction between atoms and molecules. Until then, the concept was still unclear. And what he did was, he explained was, he took 2 volumes of hydrogen and reacted it with 1 volume of oxygen, and it formed 2 volumes of water vapor. Next was the Dalton's atomic theory. This is quite important, and this was proposed by Dalton is 1808. So let us go through it one by one. He said that matter consists of indivisible atoms. That is, the atoms in the matters can't be divided, and all the atoms of a given element are identical. That is, they have identical properties, including the identical mass as well. And atoms of different elements are different from each other in mass, and compounds are formed when atoms of different element combines in a fixed ratio. Dalton's atomic theory. This was proposed by Joel Dalton in 1808. Let us go into it one by one. He said that matter consists of indivisible atoms. That is, the atoms of the matter can't be divided. And all atoms of a given element are identical. When you take an element, all the atoms of that element are identical, including the identical mass as well. And atoms of different elements differ in masses. And compounds are formed when atoms of different elements combine in a fixed ratio. And chemical reactions involve reorganization of matter. That is, they are neither created or not destroyed in chemical reaction. Next, let us discuss about atomic and molecular masses. You know that atoms are very, very small, right? So even the masses of the atoms and molecules will be very small. So first, let's discuss about atomic masses. To find out the atomic masses, they have taken one reference, that is mass of one carbon-12 atom. Carbon-12 is nothing but one of the isotopes of carbon. Carbon has 3 isotopes and one among those is carbon-12 isotopes. And one atomic mass unit is defined as exactly the mass equal to 1/12 the mass of one carbon-12 isotope. That is 1 AMU is equal to 1.66 into 10 power minus 24 gram. And for example, mass of an hydrogen atom is 1.67 into 10 power minus 24 gram. So thus when you have to convert it into AMUs, what you do is take the mass of the hydrogen atom, that is 1.67 into 10 power minus 24, divide it by 1 AMU, that is 1.66 into 10 power minus 24 gram. So the resulting answer will be your mass of the hydrogen atom in AMU units, but at present AMU has been replaced by U. Next, average atomic mass. So this came into picture when there were isotopes. So as I just said, carbon has 3 different isotopes. So you can't have a one basic atomic mass. So what they did was take the average of atomic masses of all the isotopes. So for example, again carbon, when you take, there is 3 different isotopes, that is carbon-12, carbon-13 and carbon-14, and the average atomic mass was simply obtained by multiplying the relative abundance of all the isotopes into the atomic masses. So that is what they did in this case, that is they took the average atomic mass of carbon-12, that is 0.988, into the relative abundance, that is 98.8%, right? So they considered it as 0.988 into 12 AMU, and the next one is carbon-13 isotope, and next one is carbon-14 isotope, and they added up all the three to get the average atomic mass. Next is the molecular mass. Molecular mass is nothing but the sum of the atomic masses of all the elements present in the molecule, right? All elements make up the molecule. So when you take the atomic masses of all the elements, it forms the atomic mass of the molecule. So atomic mass of each element into the number of its atoms gives the molecular mass, and then we add them up. For example, in case of methane, that is CH4, there is 1 unit of carbon and 4 units of hydrogen, right? So the average atomic mass of carbon is 12.01 U, we just found it out, and that of hydrogen is 1.008 U into 4 times, that gives the molecular mass. And for another example, in case of H2O, twice the atomic mass of hydrogen and 1 times the atomic mass of oxygen, and then add them up, we will get the molecular mass of water. Next is the formula mass. So there were substances like sodium chloride and all, which do not contain discrete molecules as the constituent units, but they have ions, like positive ion was the sodium ion and the negative ion was the chloride ion, which combine together to form the sodium chloride. That is a 3-dimensional structure. In this case, they couldn't find out the mass by the previous calculation. So what they did was they formulated a formula mass, and according to that, it's nothing but the mass of all the elements, that is atomic mass of sodium and atomic mass of chlorine together gives the atomic mass formula mass of NaCl. So atomic mass of sodium is 23 U and atomic mass of chlorine is 35.5 U, and it together gives 58.5 U, which is the formula mass of total NaCl. Next, mole concept and molar masses. This is a very important concept in this topic, and let us see what it is. In SI system, we already discussed, when I discussed about the 7 bases in case of SI system, the 7th base, that is to find the amount of a substance, the SI unit was mole. So let us discuss what it is. SI unit of amount of substance is a mole, and the symbol is MOL, mole. So 1 mole contains 6.022 into 10 power 23 elementary entities, and these entities can be atoms, molecules, or anything as such. And this number 6.022 into 10 power 23 is called the Avogadro's constant, that is Na. And if you convert it in the terms of unit mole inverse, you call it Avogadro number. So Avogadro number is nothing but 6.022 into 10 power 23 mole inverse. So many entities, I said, right? Atoms, molecules, or any other particle constitute 1 mole of a particular substance. For example, 1 mole of hydrogen atoms has 6.022 into 10 power 23 atoms. 1 mole of water molecule has the same thing, 6.022 into 10 power 23 molecules. And in case of sodium chloride, it's a formula unit, right? So 1 mole of sodium chloride has 6.022 into 10 power 23 formula units of sodium chloride. Next up, the mass of 1 mole of a substance in grams is called molar mass. Molar mass. So mass of 1 mole of a substance in grams. The molar mass in grams is numerically equal to atomic or molecular or formula mass in U. That is, molar mass of water is 18.02 grams per mole. That was the value we obtained in U also, right? And molar mass of sodium chloride is 58.5 gram per mole. Next is percentage composition. This is to find the mass percentage of an element. Mass percentage of an element is nothing but the mass of that element in the compound and the molar mass of the entire compound into 100. Since it's percentage, we multiply it by 100. So you are finding the percentage of the element in the entire compound, right? So what you do is take the mass of the element and the molar mass of the entire compound and multiply it by 100. It's as simple as that. So for example, molar mass of water is 18.02 grams, okay? So what does water consist of? Hydrogen and oxygen, right? So if you want to find the mass percentage of hydrogen, there are 2 atoms of hydrogen into 1.008 divided by 18.02 into 100 gives the mass percentage of hydrogen. And since there is only 1 oxygen atom, mass percentage of oxygen is nothing but 16.00 by 18.02 into 100. Similarly, there is another example. Molecular formula of ethanol is C2H5OH, and to find the molar mass of ethanol, what you have to do? 2 times C divided by the molar mass of ethanol into 100, right? The same way in all the 3 cases. You will find the mass of each element in the entire compound. Next, empirical formula for molecular formula. What is empirical formula? Empirical formula represents the simplest whole number ratio of various elements, atoms present in the compound. Next, empirical formula can be determined if we have the mass percent of various elements present in the compound. So it just represents the whole number ratios of all the elements present in the compound. And if we have the mass percent of all the elements, like the percentage of a particular mass percent of particular element present in the compound, if we know that of all the elements, we can calculate the empirical formula. So there are few steps to determine the empirical formula. First step, convert the mass percentage. If we are given with the mass percentage, convert the mass percentage to grams. Next what you do is convert the grams into number of moles of each element. Now you have the number of moles of each element. Now take the least value among all this and divide each of the number of moles divided by the least value. And now mention the symbol of elements present in it, right? If it's ethanol, you have C2H5OH, right? So what you do is you mention the symbols, that is C for carbon, H for hydrogen, and then write down the numbers obtained along with them, and then write the molecular formula. And interestingly, mass is interconverted to moles and number of molecules. All these mass, moles and number of molecules are interconvertible. Next, concentration terms. These are very important and you will be using them in a lot of calculations. So 4 concentration terms are mass percent, mole fraction, molality and molarity. You require this to find the concentration or the amount of substance present in the matter. So first, how is mass percentage found out? Mass percentage is nothing but the mass of the solute in the entire solution, and since it's percentage into 100, fine. So mass percentage is given by mass of the solute by the mass of the solution into 100. Next is the mole fraction. Mole fraction is nothing but number of moles of a particular component in the entire solution, in the entire solution. So if you want to for say for example, you have two components, that is A and B. So if you want to find the mole fraction of element A, what you do is number of moles of A divided by number of moles of entire solution, that is number of moles of A plus number of moles of B. This gives the mole fraction of the A. Next, molarity. Molarity is a very important calculation which we'll be doing very frequently. Molarity is nothing but the number of moles of the solute present in 1 liter of the solution. So how do you calculate it? Molarity is equal to number of moles of solute divided by volume of solution in liters. Next is molality. Molality is nothing but number of moles of solute per kg of the solvent. So how do you calculate it? Number of moles of solute divided by mass of the solvent in kg. Let us take one example A and discuss it up. First, for the mass percentage, these are from the NCERT. The solution is prepared by adding 2 grams of substance A to 18 grams of water. Calculate the mass percent of the solute. So for mass percent, what do you require? Mass of the solute by mass of the solution into 100, right? So mass of A is required. So mass percentage of A is required. Mass of A is given to be 2 grams divided by mass of solution is 2 grams plus 18 grams into 100. We'll get that answer. Next, to calculate the molarity of NaOH in a solution prepared by dissolving its 4 grams in enough water to find 250 ml of the solution. Fine. Molarity is nothing but number of moles of solute by volume of the solution in liters. So number of moles of solute is nothing but mass of NaOH by molar mass of NaOH, right? How do you find the number of moles? I just explained. So mass of NaOH is 4 grams divided by molar mass of NaOH. You just find out the molar mass of NaOH, Na plus O plus H, and then that is nothing but 40 grams. So divided by 250 ml. This is in ml. When you convert it into liter, it becomes 0.250, and the obtained answer is as follows. Next, to find the molality of the solution. Molality of the solution is given by number of moles of solute by mass of the solvent in kg. So now we have almost gone through most of the concepts in this chapter, and thank you.